Hello to everyone. I am Leila, a PhD student at the Research in Intelligent Informatics, Mathematics and Application Laboratory and the University of Science and Technology of Algiers. I am presenting an experimental study on sentiment classification of Algerian texts. Our presentation is organized as follows. We'll start with an introduction to lay out in first the context of our work. Then present the publicly available resources that we exploited, followed by the methods and models we implemented and tested. Afterwards, we will present the experimental results and the error analysis. Lastly, we end with a conclusion and give some perspectives to our future works. Opinion and emotion analysis help extract and analyze subjectivity expressed through written texts. Social media proliferance allowed people with different backgrounds to share and engage in discussions on various topics. This phenomena led to what the 21st century described as data explosion. Researchers and marketers sought this opportunity to exploit such data in order to gain meaningful insights over different domains, such as e-commerce, politics, and cinema. Over the last 2 decades, researchers were engaged to assess and analyze different opinions in the web. Therefore, several approaches were proposed, ranging from simple handcrafted to complex and automated methods, using different types of features. However, the Arabic language and its dialects did not gain a lot of attention and still suffer from a lack of resources, especially Arabic dialects, which is a non-standard Arabic variety. Among the 3 varieties of Arabic, we are focused on the latter, the dialectal Arabic. It is worth mentioning that the highest proportion of available resources and research publications in Arabic opinion and emotion analysis are devoted to the modern standard Arabic, which is the formal Arabic. Regarding Arabic dialects, the Middle Eastern and Egyptian dialects receive the largest share of all research efforts and funding. On the other hand, very little work has been conducted for the Maghrebian dialects. Heading towards North Africa, the linguistic situation becomes more complicated, as there is no dialect derived only from Arabic, but rather multilingual dialects. Hence, our interest in Maghrebian dialects in general and the Algerian dialect in particular, which was inspired not only by the Arabic but also by Tamazight, the first language of the region, as well as other foreign languages. The table below represents some examples of Algerian vocabulary derived from several languages. If we look at the last example, we can see that the term has several derivations, and this is due to the fact that each region has its own dialect, which can be found today on social networks. Also, despite the fact that the Algerian dialects were inspired by other languages, they have a phonologically and morphologically modified vocabulary, something that we must take into consideration in our analysis. Therefore, we experimented with different types of Algerian text using known approaches that yielded good results in other languages and dialects. However, the publicly available resources for the Algerian dialects are scarce. To perform our experiments, we relied on 2 publicly available corpora. The first dataset text contents were posts and comments collected from Algerian Facebook pages. The second is the corpus that we created in a previous work, composed of Algerian labeled tweets. The third is the combination of the first 2 corpora, resulting in a larger corpus to help test the validity of our models on mixed data sources in the same dialect. Facebook comments versus tweets. The data sets have been pre-processed using standard preprocessing techniques, including the removal of URLs, user mentions, punctuation marks, as well as long and repeated characters that denote exaggerations. We also removed stop words, all diacritics, and finally normalize Arabic letters such as the alif and ya and hamza. For lexicon-based approaches, we make use of several available Arabic sentiment and emotion lexicons manually annotated, including the Arabic translation of Bengli's lexicon, MPQA subjectivity, and NRC hashtags. As we are specifically targeting the Algerian dialect, we finally rely on our manually built lexicon named Twilex. We target for the first time Algerian dialect that lacks available vectorial representation as far as we know, where we experimented with several approaches including feature and lexicon-based, where given a text, we count the number of positive and negative words that belong to one of the aforementioned lexicons. Classical machine learning methods, namely SVM, naive Bayes, random forest, and maximum entropy, using different bag of word features such as unigrams and bigrams frequency. The bigrams are represented as 2- model. Deep learning models, including convolutional neural network and long short-term memory, where we rely on two types of representations. In the first, we leverage existing pre-trained embeddings models at different unit levels, word, subword, and character. In the second, we make use of dialect-specific embedding integrated with the classifier learning as part of the deep learning models. The first embedding model used is an Arabic word-to-vec-based model named Arabic. We tested the 4 models trained on tweets. The best results were given by CBAO 100. The second is the Arabic model of fast text. The third is the contextual model BERT, where we tested the BERT multilingual model, to which we added a classification layer. The last is a character language model given by Flair. We tested the 2 Arabic models separately and stacked as part of a recursive neural network classifier. For the dialect-specific models, we used an embedding layer with randomly generated weights uniformly distributed between -0.05 and 0.05 as part of a single convolution CNN and an LSTM. In both models, a max pooling layer is used to capture interactions between the features obtained by the filters followed by a softmax classification layer. The results are encouraging. We set a baseline using known models. The best results were obtained using unigrams and bigrams with SVM. For the lexicon-based methods, we tested each lexicon represented previously. The best results were obtained using our lexicon Twilex, as well as the Arabic translation of Bengli's lexicon, Emolex, and the Arabic hashtag. The deep learning models gave the best results, outperforming the baseline and the lexicon-based approaches. The best results were obtained using dialect-specific embeddings as part of the CNN classification learning process. However, the dialect-agnostic pre-trained models, such as Arabic and fast text, gave lower results, especially the Flair contextual character embedding. Here we provide an error analysis of the instances for which the predictions of our best performing models and the manual annotation differ. Looking at some examples that were predicted incorrectly, we understand that the most recurrent errors occur when a text contained both positive and negative words, in addition to misspellings and grammatical errors, as well as the lack of context, especially for short text, making it hard to predict the correct class. There are also some examples which do not carry a sentiment but were given a positive or a negative class. Overall, poorer results are obtained due to the significant phrases or words present in the text of positive class which may fall under the negative class in the training set or vice versa, possibly leading to misclassification. In addition, the out-of-vocabulary problem, where many words have been skipped, can also be another reason. The main findings of the experiments presented in this work are that we feel corpus will help increase research in sentiment analysis of Algerian texts, as well as explore new techniques in this field. Deep learning models give better performances for Algerian text sentiment analysis compared to classical machine learning and lexicon-based approaches. Dialect-specific embeddings are more effective than dialect-agnostic embeddings for Arabic text classification. Randomly generated weights outperform pre-trained models. For future work, we plan to further enrich the proposed resources and tools for the sentiment analysis of Algerian texts, experiment with the newly published BERT language model, as well as herein. Extend our models to other Maghrebian dialects and other classification tasks, including the multi-label classification. Several other opinion and emotion detection tasks in this domain are also interesting and investigation-worthy, such as the prediction of the fine granularity scores of reviews, the construction of semantic models which can provide stronger support for domain and context to avoid ambiguities, and improving the multilingual opinion and emotion detection. Thank you for your attention.